Hello everyone, my name is Dr. Seema Singh and today I will talk about capillary action. So first of all we need to understand what is capillary. So capillary is a thin tube, thin glass tube having very small bore size, or we can say narrow bore. Okay. So we need to understand what is capillary action with this capillary. When this capillary is inserted in a liquid container, in a container containing a liquid, what happens? See, suppose we take a capillary of small size and we dip this capillary inside this container. Two things can happen, right? Let's see what. Here we can see the liquid has rised in the capillary, so it is ascent. The liquid has ascent in the capillary, and in second case the level of liquid has fall down, so it is descent. So the capillary action is the phenomena when a small capillary is dipped in the liquid either ascend or descend in the capillary. So this phenomena is known as capillary action. But what are the forces responsible for this capillary action? Okay. So why in one case the liquid has risen and in another case the liquid has lowered down in the capillary? See, there are two kind of force. One is cohesive force, which acts between the molecules of force between the molecules of same substance. And adhesive force, which act between the molecules of different substance. So what happens when we dip this capillary inside the liquid? Force of attraction, this cohesive force and adhesive force, comes into the action. If this cohesive force, that is the force between the molecules of same substance, if this cohesive force between the liquid molecules is like C, suppose C, and adhesive force between the molecules of different substance, force between the molecules of liquid and the surface of this capillary is A. If the adhesive force A is greater than cohesive force, this liquid will ascend in the capillary. Why? Because there is stronger force between the molecules of liquid, these molecules of liquid, and these molecules on the surface of capillary. So if this adhesive force is more, the liquid will rise in the capillary. Okay. What happens in second case? In second case, this liquid descend in the capillary. Why? Because this cohesive force is stronger than the adhesive force. The liquid molecules have stronger force of attraction than the force of attraction between the molecules of liquid and the molecules on the surface of this capillary. So in that case, when the cohesive force is stronger than the adhesive force, the liquid will descend in the capillary, while when the adhesive force is stronger than cohesive force, the liquid will ascend in the capillary. So this cohesive force and adhesive force are responsible for this capillary action, right? So we need to understand what happens. So there are two examples where the adhesive force is stronger than the cohesive force and cohesive force is stronger than the adhesive force. What are the examples? Water molecule. In water molecule, the cohesive force between the water molecules is lesser. Okay, so here adhesive force A is stronger than the cohesive force. That is force of attraction between the water molecule and the molecules on the surface of capillary. What is this capillary? It is made of glass. So it is silica. It is stronger than the force of attraction between water molecules. Okay. So in that case, the liquid will ascend in the capillary, right? And in case of mercury, this cohesive force is stronger than the adhesive force. The edgy interaction is stronger than edgy silica interaction. Here I am taking silica because this capillary is made of glass, and we can say that the silica molecules are present on the capillary. So this force of attraction edgy is stronger than edgy Si. So in that case, C, cohesive force is stronger than the adhesive force, and in that case the mercury liquid will descend in the capillary. So this is how capillary action takes place due to the two kind of forces, cohesive force and the adhesive force. Now let's understand this phenomena in terms of pressure. Okay. Let's take a container filled with liquid. Suppose here we are taking water as a liquid, and when we dip any capillary inside this tube, inside this container, what happens? Here I am drawing this little bit larger to understand the phenomena. When we dip this capillary, there is one curvature. This meniscus is formed here because the liquid is filled in this capillary. So what happens if we consider 2 points, suppose A and B? Okay, the pressure at point A is atmospheric pressure. Okay, the pressure at point A is atmospheric pressure, and pressure at point B is lower than the atmospheric pressure. Okay, so if we take any point equivalent here, suppose C, the pressure at point C is P atmosphere. Let's write it. Pressure at point A is P atmosphere. Pressure at point C is P atmosphere, but pressure at point B is lesser. P atmosphere minus 2T by R. Okay, what is R? R is radius of curvature. Radius of curvature of this meniscus formed here. Okay, and what is T? Surface tension. So here we can see the pressure at point B is lower than the pressure at point C. So we can see there is the pressure outside the capillary is more than the pressure inside the capillary. So there is a tendency to maintain the equilibrium. The liquid molecule will transfer from higher pressure to the lower pressure, and this liquid level will rise in the capillary. So here is a point A, here is a point B, here is a point C, and now suppose here is a point C prime. Okay. To maintain the equilibrium of pressure at the same level of this liquid in the vessel, the liquid will rise in the capillary to maintain the pressure equilibrium in this container, right? So what happens, the liquid level has risen now. So in this new situation, when the liquid has risen, the pressure at C prime is same as the pressure at C. Okay, pressure at C prime is same as pressure at point C. Let's mark it as equation 1 and this as equation 2. Okay, now pressure at C prime, that is P C prime, is equal to pressure at B plus H rho G. What is H here? H is the rise in liquid, the height of this liquid which has risen from previous one. Okay, what is rho? Rho is viscosity of the liquid and G is gravity. Okay, so now we have seen that PV is equal to P atmosphere minus 2T by R. When we will substitute this value, what we'll get, PC prime is equal to P atmosphere minus 2T by R plus H rho G. Mark it as equation number 3. But what is PC? PC is equal to P atmosphere and PC prime is equal to PC. So from this equations we can say PC prime is equal to P atmosphere minus is equal to P atmosphere minus 2T by R plus H rho G. From this equation we can find out what the value of H. If we cancel this P atmosphere, we'll get H is equal to 2T by R into 1 upon rho into G. But what is R here? R is radius of curvature. Now we can find out the value of R in terms of another equation. Let's try this here. Suppose if we have in this container if this is the capillary and this is meniscus, I'll draw it as larger one. Okay, so this is radius of curvature, capital R, and if this is the diameter of capillary, then R would be the radius, small r. Okay, suppose if we draw one tangent here, this is filled with liquid. Okay, so this angle is theta. Theta is the contact angle of this liquid. Contact angle is the angle between the liquid and the surface of this capillary. So if this is theta, then this is also theta. And if we draw this as perpendicular 90 degree, then the relation between R, that is radius of curvature, and small r, that is radius of this capillary, is R is equal to R upon cos theta. So if we substitute this value of R in that equation, we will get H is equal to 2T cos theta upon small r, that is radius of this capillary, rho into G. From this equation we can find out the value of H, that is the height of liquid in the capillary. So this is how we can calculate the height of the liquid rise in the capillary when the capillary is dipped in the dipped into the liquid. So this is all about the capillary action. One of the most well-known example which we see in nature regarding the capillary action is the absorption of water in the plants. What we see in plants, what we see, these, suppose if this is a plant and these are the roots of this plant, the water molecule passes from the soil to the trunk and to the leaves. But how it happens? This water molecule is passing against the gravity. Because in plants we have xylem. Xylems are nothing but capillaries present in the plants along the length. So what is the role of this xylem? This xylem helps in absorption of water. The water get absorbed in the xylem and it get transported from these roots to the trunk and to the leaves. So this is how capillary action takes place in the plants, and the water absorption and nutrient absorption is carried out with the help of capillary action, with the help of this xylem. So this is all about the capillary action and its example in nature which we see in everyday life. And one more example of this capillary action which we see, if we dip a paper in water, the water get absorbed in the paper. That is also due to the capillary action. Okay, thank you.